This video is about dot products and cross products of vectors. In order to understand this video, you have to first know about what is vector, how to calculate the magnitude of vector, and also what is determinant. If you have any problems with these terms and concepts, you may refer to the YouTube links in the description. We have two types of multiplication for vectors, dot product and cross product. We will first go through some definitions and examples. At the end, there will be some exercise for practice. Now, let's have a look at the dot product first. For two non-zero vectors u and v, and theta is the angle between them, the dot product or scalar product of u and v, which is denoted by u dot v, is defined in two ways. Algebraically, it is the summation of all ui and vi, while geometrically, it is the product of the magnitudes of u and v and cosine theta. Here is the proof of u dot v equals to the product of the magnitudes of u and v and cosine theta. For some special cases, for instance, the vector u and v are parallel. If they are pointing in the same direction, u dot v is simply the product of the magnitudes. If they are in opposite directions, u dot v becomes negative of the product of the magnitudes. In particular, if vector u and v are the same, then we have u dot u equals to the square of its magnitude. If they are orthogonal, that is perpendicular to each other, their dot product must be zero. For unit vectors I, j, and k, dot product of itself equals to 1, while that of any product equals to 0 because they are perpendicular to each other. Here are several properties of dot product. Note that u, v, and w are any vectors, and k is a real number. Now, let's try some examples. Suppose the length of a vector A is 4 units, and that of vector B is 1 unit, and the angle between A and B is 60 degrees. The value of A dot B can be found by 4 times 1 times cosine 60 degrees, which equals to 2. Example 2. Given that two vectors A and B, recall that vectors I and j are unit vectors. Part A. Find the value of A dot B. The dot product can be found algebraically, that is 3 times 5 plus 2 times minus 1, which equals to 13. Part B. Hence, find the angle between A and B. First, let theta be the angle required. Then, by change of subject, cosine theta equals to vector A dot vector B over length of A times length of B. After calculation, cosine theta equals to 1 over square root 2, and theta equals to 45 degrees. Dot products can be applied in two areas. The first one is finding the projection of a vector onto another vector. In a figure, suppose C is the foot of perpendicular from B to OA. Then we call vector OC the projection of V on U. The length of vector OC can be found by OB cosine theta, which is magnitude of V times cosine theta. Since we have learned that u dot v is the length of u times length of v times cosine theta, then magnitude of v times cosine theta and thus the length of OC equals to u dot v over length of u. As vector OC is in the same direction as vector u, the vector OC can be found by multiplying its length with the unit vector of u, that is, u dot v over length of u times u over length of u. The second one is determining the orthogonality of two vectors. Since the dot product of two non-zero vectors is zero, if and only if they are perpendicular to each other or orthogonal. This property can be used to test whether two given vectors are perpendicular or not. The dot product part ends here. Next, let's talk about cross product. Suppose we have two non-zero vectors u and v in a three-dimensional space. The cross product or vector product of u and v, denoted by u cross v, is the vector which is perpendicular to both vectors u and v. The direction of u cross v is defined by the right-hand rule. Vectors u, v, and u cross v always obey the directions as shown in the figure. From the right-hand rule, u cross v is the length of u times length of v times sine theta times the unit vector n, whose direction is defined by the right-hand rule, and its magnitude equals to the length of u times length of v times sine theta. Algebraically, if vector u equals to x1i plus y1j plus z1k, and vector v is x2i plus y2j plus z2k, then u cross v can be calculated by this determinant. In case of two parallel vectors, the cross product is zero, no matter the vectors are pointing in same or different directions. For identical vectors, the cross product is also zero. If the two vectors are perpendicular to each other, their cross product is the length of u times length of v times unit vector n, while the magnitude of u cross v equals to the length of u times length of v. For unit vectors I, j, and k, the cross product of itself is zero. The cross product of any pairs equals to the next vector in clockwise direction as shown in the figure, and the cross product of any pairs equals to the negative of the next vector in the anti-clockwise direction. Here are several properties of cross product. Note that u, v, and w are any vectors and k is a real number. Now, let's have a look at one example. For two vectors a and b, the cross products can be found by the determinant as shown. After calculation, a cross b equals to minus 10i plus 26j plus 11k. Dot products can be applied into two areas. The first one is calculating the area of parallelogram. From the figure, the area of parallelogram OBCA equals to length of A times length of B times sine theta. That is magnitude of A cross B. Since the area of triangle OBA is half of that of parallelogram OBCA, the area of triangle OBA can be found by dividing the magnitude of A cross B by half. The second application is the calculation of the volume of parallelogram by scalar triple product. Parallelogram is a prism with four faces of parallelograms. Regarding to the figure, theta is the angle between vectors B and C. Alpha is the angle between vector A and cross product of B and C, and h is the height of the parallelogram. The volume of parallelogram equals to the base area times height, which is length of B times length of C times sine theta times h. As h equals to length of A times cosine alpha, the volume then equals to magnitude of B cross C times length of A times cosine alpha, which equals to magnitude of A dot bracket B cross C. A dot bracket B cross C can be calculated by the determinant shown. Furthermore, if A dot bracket B cross C equals to 0, That means the volume of parallel part is 0. So vectors A, B, and C are coplanar. Now we have finished the tutorial part. Here are some exercises with solutions behind. You may test your understanding of this topic. This is the end of this video. Thank you for watching.